So for section 7, we're going to be graphing square roots. And everybody, if you learn today's lesson, the next lesson is going to be super easy as well. It just adds one change to it, and then the rest of it's all the same. So let's get this down real well today, and you'll help yourself out a lot on tomorrow's notes and on the test next week. So to graph a square root, the issue is that there's only certain numbers that have nice square roots. Give me some numbers that I can take the square root of and get a whole answer. 4 is a great one. Hey, somebody said 1. It took us a while to figure that one out in last period. 4, 1. What else? What was that? 0 is another great one. What was it? 9, not 6. Did I hear 36 maybe? 36 is going to be really far off our graph. What are 2 more numbers bigger than 9? 16, 25. Those are the ones we're looking for here. Every time you're asked to graph a square root graph, you're going to use these numbers because they're the only ones we can take square roots of and get a whole number answer. Does that make sense to everybody? So right here, I'm going to show you the work. The work for each of these, it's the square root of 0, but that gives us 0. The square root of 1 gives us 1. Square root of 4 gives us 2. Square root of 9 gives us 3. Square root of 16 gives us 4. Square root of 25 gives us 5. Does everybody understand why I picked those values for x and how we got those answers for y? Just taking the square root of each of them. And we picked them because we could take the square root of them. So now when I graph that, it means I have the point 0, 0, 1, 1, 4, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. And then the rest of them are off the graph. Does that make sense to everybody? Typically, these are the only 4 you're going to use. Sometimes you may only be able to get 3. Please get at least 3. If you get 2 points, it's really hard to tell if you've got the graph right or not. Now, can I put negatives into a square root? I hear yeses and nos. Yes, I can, but then I get imaginary numbers. Does that make sense? So it's a little bit of a special case. And I can't graph imaginaries. So we're not going to put negatives in here. Okay. So I'm going to go ahead and just connect these dots starting at 0 and going up like this. This is the general shape of our square root graph. All of your graphs should look something like this. They have a distinct starting point. One point that they start at, and then they go up and kind of curve over and flatten out. Now, the general form for this graph then is y is equal to a, that did not look like an a square root of x minus h plus k. H is inside the square root, k is outside the square root. All of these values do the same things that they did last semester. K shifts us up and down. H moves us left and right. Come on. And again, that one's always the opposite of what you think because of the minus sign. So K is up and down, H is left and right. The A value is going to be what we multiply or another way of saying it's the vertical stretch. It's whether our graph gets stretched taller or gets squashed down or flipped over. So we're going to call this vertical stretch. That vertical stretch only affects the y values, if you want to make a little note for yourself. That is all you need to know to be able to graph these. Let's try it. So to begin with, for number 1, I'm starting with the same points every time. 0, 0. Let's zoom in a little bit. Starting with the point 0, 0, 1, 1, 4, 2, 9, 3, which is off the graph. You could go in to your notes and your homework and put those same points every single time. 0, 0, 1, 1, 4, 2, 9, 3. The reason is we're going to take those points and manipulate them to get the graph. So here, the +3, everybody, is this +3 an H or a K value? I'm hearing both. Which is it? Is it inside the square root? It's outside. That means it's a K. Does that make sense to everybody? Outside numbers K shifts up and down. So this right here, if you have multiple colors like colored pens, pencils, go ahead and get them out right now. You don't have to have them, but it will help. So we're going to move all our points up 3. To graph this, it's as easy as taking those points that you have, those 4 points that we started with, and just moving them all up 3. So up 1, 2, 3. Up 1, 2, 3. And really, you could cross off each point as you do it. This point up 1, 2, 3. Cross off the old one. Up 1, 2, 3. Cross off the old one. And then just draw on your sketch. There is my graph. That is all you have to do for these. Start with this. Start with the original points. Find the shift. Make your sketch. Does that make sense to everybody? All right, so let's come down here now. It asks us for the domain and range. The domain and range, same as last year, except it's a little bit shorter here, because what you're going to do, find that point that was 0, 0, okay? These graphs usually go 0 to infinity on the x direction to the right, and they go from 0 to infinity on the y's for the range. But if it's been shifted, this point, this starting point is shifted. So this point is now 0, 3. I'm going to put it down here, 0, 3. The 0 is the start of your domain. Your domain's going from 0 to infinity. The 3 is the start of your range. Your range is going from 3 to infinity. Does everybody understand where those came from? Looking at the graph, the farthest left was 0, 0 to infinity. The farthest up, we started at 3 and then went up above that. Let's hit another one. So to start off here, we're going to start with the same exact points. 0, 0, 1, 1, 4, 2, 9, 3. Always the same 4 points. Now we have a -2. That's an H value. This is going to move us right 2. Remember, the H value is the opposite direction of what you expect. So we're going to move right 2. Take those same points, move them all right 2. So this guy right 2. This guy right 2. Right 2. And right 2. Connect the dots. There's my graph. That simple. Now, this starting point here is where I get my domain and range from. That point is 2, 0 this time. So my domain is 2 to infinity. My range is 0 to infinity. Anyone have questions on those? All right, let's do another one. Number 3. This one has a negative out in front. It's got an A value. Start with the same 4 points. So we're starting with the point 0, 0, 1, 1, 4, 2, 9, 3. So there's my points. Now, before, everybody, are you listening? Before you do the HK shift, you're going to multiply the Y values by A. That's the A value. The negative out in front is your A value. And so we're going to multiply all of our Y's by -1. All the Y's by -1. So 0 times -1 is still 0. This one doesn't move. But 1 times 1, or sorry, 1 times -1 is -1. 2 times -1 is -2. 3 times -1 is -3. So it only affects the Y values. It does not change the X's. Now I do my shifting, just like before. So this one, we're going to shift left 2, or sorry, left 1 down 2. Left 1 down 2. So each point, left 1, down 1, 2. Cross off the point we just did. Left 1, down 2. Cross off the point. Left 1, down 2. And left 1, down 1, 2. Come on, there it goes. Connect those dots. Now, a couple quick things here. I'm going to give you a little preview of what's coming up. They're going to ask you for X and Y coordinate, or X and Y intercepts. Yes. You actually wouldn't, because when you flipped it, when you moved it down 2, when you try to flip upside down, then you're going to flip the down 2 also. Does that make sense? Technically, the shifting left and right would be fine. You could do the shifting left and right first and then the flipping. But I find it's easier just to think of it as do the multiplication first, the flipping and the multiplying, the stretching. Do multiplication first, then do the shifting. So does everybody see this point right here? That point is my Y-intercept. If they ask you for your Y-intercept, I already have it on this graph. Is this graph going to have an X-intercept? Right, it's below the X-axis and it's going down. It's never going to hit the X-axis. So quick note with that. Let's get the domain and range. Domain, this point, that starting point there is -1, -2. -1, -2. So that means my domain is -1 to infinity. Wait a second, we've got a problem with the range though. Normally it's -2 to infinity, right? But this one's not going up. It's -2 down to -infinity. Remember, we always go smallest to greatest. So you're actually going to write that as -infinity to -2. -infinity to -2. Does that make sense? Are we okay there? Let's see. I think that's probably good. I'm going to do one more for you guys, then you guys can try an example. We should have plenty of time here. So Number 4, turn to the next page. Same exact thing. Same exact thing, but it's got a 2 out in front instead of a -1. But you do it the same way. You multiply by 2. So I'm going to take all my points. What are the points that I start at? 0, 0, 1, 1, 4, 2. And then again, you can try the 9, 3 out here as well. So all of the y coordinates get multiplied by 2 this time instead of -1. So 0 times 2 is still 0. That point doesn't move. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 3, 4, 5, 6. So notice how it stretches our graph up instead of flipping it upside down this time. All of our points just got stretched upward. Now, let's do the shifting. So the shift here is left 2, up 3. Oops. Left 2, up 3. So that means each point left 2, 1, 2, up 1, 2, 3. Left 2, up 1, 2, 3. Left 1, 2, up 1, 2, 3. And this guy's way off the graph. Left 1, 2, up 1, 2, 3. We're like up here somewhere. Now, I'm using different colors so I can keep track of everything. If you need to erase your old points as you go, if you're just using a pencil, that's fine. Just make sure it's obvious where your final graph is. So here's my final graph. Right there. Does that make sense? So now they ask you a few other questions here. Domain and range. Okay, well, we started at the point -2, 3. So the domain was -2 to infinity. The range was 3 to infinity. X and Y intercepts. Does this graph ever cross the x-axis? No, it's above it the whole time. So no x-intercepts. X-intercept, none. Y-intercept. There is one, but I don't know where it is. It's right here. It looks like 6, doesn't it? But I don't have a point there. So it's probably not actually 6. It's probably somewhere near it. To get the x-intercept, we make y0, but there is none. To get the y-intercept, we make x0. And it's actually really easy. Just plug in 0 for x. So that means 2 square root of 0 plus 2 plus 3. All I want you to do is simplify the inside of the square root. 0 plus 2 is 2. 2 root 2 plus 3 is your y-intercept. Now, if it had simplified all the way, if it was 2 root 4 plus 3, I'd take the square root of 4, I'd multiply by 2, I'd add 3. This one doesn't. That is my y-intercept. If you approximate with that with a calculator, it's about 6, but not exactly. Does that make sense to everybody? Now, open interval where g is decreasing. Is this graph ever going down? Not from left to right, which is how we always read graphs. So none. Just like some of the graphs we did before, it's either always increasing or always decreasing, except it's restricted by the domain, right? So if it asked for the open interval where it was increasing, I'd say the domain, -2 to infinity, but with parentheses. Where is it negative? That means below the x-axis. Is this graph ever below the x-axis? No. So again, none. Let's go ahead and do one more example here, because this one has a 1/2 in it. So the 1/2 here Actually, you know what? I'm going to be nice to you guys. I'm going to do the 1/2 one that's in the homework instead of the notes. Okay. But before we do it, I do need to show you one other thing here. Everybody look at 6. 6 is written wrong. It's not in the format that we're used to. Take the 4 and put it on the end. This should be -3 root x plus 1 plus 4. Now it's what we're used to seeing. Does that make sense to everybody? So it's addition or subtraction. As long as you keep the negative sign on the square root, yes. Saying 4 minus 3 is the same thing as -3 plus 4. Does that make sense? That still works. That's all I'm doing right here. That way it's easy to see that 4 is the k value. So now let's go ahead and do that one from the homework instead. Let's do number 10. Everybody go to the back page of the homework. Let's do number 10 all together. So for number 10, I'm going to take my same points, 0, 0, 1, 1, 4, 2. If it'll let me. There it goes. So same points as always, 0, 0, 1, 1, 4, 2, 9, 3. Now I'm going to multiply those points by 1/2. Okay? Multiply the points by 1/2. So if I do that, 0 times 1/2 is still 0. Everybody, again, I hope I have your attention for one last couple minutes. 0 times 1/2 is still 0. 1 times 1/2 is 1/2. So it's right here. It's halfway in between. 2 times 1/2 is 1. 3 times 1/2 is 1.5. Be like right here. So it squishes the graph together. Does that make sense? It brings all the points down, but it doesn't flip it upside down. Now I'm going to shift them. Just be careful with those 1/2 ones. So I'm shifting left 1 down 2. Let's try that. So left 1 down 2, right there. Left 1 down 1, 2. That puts it halfway right there, halfway between -1 and -2. Left 1 down 1, 2. And left 1 down 1, 2. Be like halfway right here. So I draw my graph in. Eventually it's going to hit the x-axis, right? We just don't see it on the graph right now. So now domain and range, same thing as we've done before. Domain, -1 to infinity. Range, -2 to infinity. Now, the y-intercept I actually already have on the graph. The y-intercept is right here. I have a nice point there at 0, -1.5. If I didn't have that point, I need to plug in 0 for x. Okay. But since I have it already, I can just say the y-intercept is 0, -1.5. The x-intercept, though, I do not have yet. And so I need to solve for x. I'm going to put 0 in for y. 0 equals 1/2 square root of x plus 1 minus 2. And I'm going to solve this like we did in section 6. I'm going to add 2 to both sides. I'm going to multiply both sides by 2 to get rid of the 1/2. Those cancel out. Times 2. 2 times 2 is 4. square root of x plus 1. I'm going to square both sides. Squared, squared. 4 squared is 16. 16 is x plus 1. Last step, subtract 1 from both sides. 15 equals x. That looks like an is. 15 equals x. That's my x-intercept, 15, 0. And that makes sense. It's off the graph to the right. At most on the test, you'll have to do that like 2 times. It's not going to be a lot, but you should all be able to find the x and y intercepts. Again, if they're on the graph, they're really easy. You just look at your graph that you already did. If they're not on the graph, you have to plug it in and find them. Now, it says find the open interval where the function is decreasing or increasing. It's increasing the whole way, right? But we don't have a graph everywhere. So I'm going to start just the domain, -1 to infinity, but with parentheses. Because remember, open intervals never get brackets. Because at -1, we're not increasing or decreasing. Part D says the average rate of change. Oh, we haven't done average rate of change since like unit 1 or maybe unit 2. And then before that, it wasn't since like freshman year. So average rate of change is just the slope. How is the x's and y's changing? They already give us the x's from 3 to 15. So that's the bottom. It's going from 15 in the x to 3 in the x. But what about the y's? Wait a second. We just found 15. Right? That's our x-intercept. So this point is actually 15, 0. If you didn't have that already, you would take the 15 and plug it in and solve. Does that make sense to everybody? The 3 I have on my graph. It's right here, 3, -1. Again, if I didn't have that, I would plug in 3 and solve. So now I have 15 minus 3 on the bottom, the x's. Now I need the difference of the y's. 0 minus -1. 0 minus -1 is +1. 15 minus 3 is 12. Again, slope formula, change in y's over change in x's. If I graph the point 15, 0, way over here somewhere, I could just count up from 3, 0, or 3, -1, I could count up 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I would get there. Does that make sense? Again, that's not a big piece, but it will show up on the test once or twice for a couple points. So your homework for tonight is numbers 1 through 6 all, and then 9 and 10. We just did number 10, right? We just did number 10. So then 9 you have to do, and then 1 through 6. What was your question? You get -1 from the domain, right? For the point at the very end, the 3, -1? No, so the 3, -1, oops, came from the actual point that we had found. We found the point at 3, and it had a y coordinate of -1. It was from this point right there. Does that make sense? Or from plugging 3 in. Any other questions there? Yeah, go ahead, sign up. You guys, you have like 15 minutes here to get a good chunk of the homework done. So go ahead and get started. Again, 1 through 6 all, 9 and 10. 1 through 6 all, 9 and 10. 9's probably the longest. The others should be pretty quick.